Well, welcome to our webinar in about the IPv6 in the RIPE database. The webinar will be about 45 minutes. I'll be doing the presentation, and at the same time, Sandra will be here to give support, but also any questions that you may have. Well, while I'm talking, I won't be able to see the questions, but Sandra will be here monitoring the chat window. So any questions you may have, just type them in, and Sandra will reply. We'll come back to you and answer your questions. It'll be 45 minutes, and then we'll still have another 10 minutes that we'll leave the chat window open, and we'll be here, so you can still ask some questions afterwards. If you're the first time that you are doing a webinar with us and you're not used to the Adobe Connect interface, I'll just do a quick tour on it. So you have the chat window. So like I said, you can just ask any questions you may have or comments. I'll be sharing my screen in a bit, and especially throughout the demos, maybe if the screen is too small, you can make it full screen on the top right icon that you have in the main panel, or even zoom in. And on the right, apart from our heads, our talking heads, and the participants list, you have on the bottom a few files that you can download, among which there are the slides that I'll be presenting, and a few subnetting charts, insider charts. There's an example of IPv6 addressing plans that may be useful later on. So feel free to download them. And furthermore, the webinar is being recorded. So we will also send you a link to the recording afterwards, and you can share with your colleagues, watch it later, and so on. Okay, so I'm going to start by sharing my screen and let you see the slides. Okay, so what we're going to be looking at today is first, since we're talking about the RIPE database, it has to do with registration and therefore has to do with distribution, the address distribution. So we'll look a bit in how IPv6 addresses are distributed. If you know how IPv4 has been distributed before, this is nothing really new because it's fairly similar, but we'll look into it as also for the ones who don't know how IPv4 had worked before. Then we'll look in how the whole IPv6 assignments work. So when you receive an IPv6 block from the RIPE NCC, what can you do with it? How's the process of creating assignments for your own network or for your customers? How much do you assign, and so on? And then we're going to look closely into the RIPE database, as all these assignments must be registered in the RIPE database, and then how can you do it? And finally, a quick word about root 6 and domain objects. That is also in within the RIPE database context, where you add some information in the RIPE database on how are your prefixes being announced and routed, and also a bit of if you're using reverse DNS, how can that be set up with a RIPE database? Okay, the first part. Oops. Yeah. The first part on the the address distribution. This is how how the distribution of IP addresses has been taking place, also already from the IPv4 times. Sorry, you have you see on the on the right side you have 4, let's say, entities. On the top you have IANA, and that is the Internet Assigned Numbers Authority, which in IPv4 used to hold the central pool. In IPv6, sort of. I'll get back to that. Below IANA, and let me see if I can use my cursor here. Yes, and you have here the RARs, or Regional Internet Registries. And does anybody know an example of a Regional Internet Registry? Well, we are the Regional Internet Registry, right? The RIPE NCC. Regional Internet Registries are the organizations like the RIPE NCC that handle the distribution of IP addresses, AS numbers, in different regions. And the RIPE NCC does this for Europe, Middle East, and Central Asia region. And then you have the local internet registries, which are which it's you, your organizations. If you are members of the RIPE NCC, you are local internet registries. And finally, in the bottom, you have the end users, and that means, well, whoever is actually using the addresses, being actually yourselves. It's either addresses that are being used on your own infrastructure, or if you have customers, these are also end users. So in how does this take place? So with IPv6, I said that in IPv4, IANA had the whole block of IP addresses. Well, in IPv6, IANA only holds the /3. So this is the IPv6 public address space that is being, let's say, handed out there. Only /3. That's only 8 parts of the whole IPv6 space. So as you see, it's still a small chunk of the whole amount of IPv6 addresses out there. From this /3, each regional internet registry has received a /12, and this /12 is what's being distributed to all organizations, to all member organizations, all the LIRs. And it is from this /12, for example, the RIPE NCC has given out to probably to each of you, to each of your organizations, a /32 at least, maybe more. And this /32 that you see here, it's what we call an allocation. What is an allocation and how it differs from, what you see below, the assignments? Well, the allocation is a big range of addresses. So as you see, /32 IPv6 is a huge amount of addresses. But this is the big block that we give to an organization, to an LIR that asks for, requires addresses. And it's obviously not going to be used in one go, but it will be reserved just for that organization to be using it for over a period of time. And the idea, yeah, is that it's reserved, and it's all these addresses are aggregated. So the main principle is also to promote aggregation of addresses. With a /32, you can immediately announce it in one go, in one /32 being announced in one prefix on BGP, and that is good because it makes things more efficient and more scalable when it comes to the routing tables. So that's the allocation. And when you receive the allocation, what you can do is start using chunks of your allocation blocks to your own addresses. So you reserve a block for your own, to your own infrastructure, for your own network, and also to your customers. So from here, you take a block, like for example, /48 for your core infrastructure. Then you're giving /56 for each of your customers. So this is when you are assigning blocks to a specific usage, and these are what we call assignments. So the difference between allocation, that's what you receive from the RIPE NCC, and assignments is what you are assigning to your specific use, either your own infrastructure or your customers. Okay. Now these assignments, which is later on what we will see when it comes to the RIPE database, these are the ones that you will have to register yourselves in the RIPE database, because the allocations is we are the ones who are giving it out with the RIPE NCC. So we register in the RIPE database, but the assignments, it will be your responsibility. Now, just another distinction here. And again, this is, if you are already familiar with IPv4, how things work, this is exactly the same, same principle. I mentioned aggregation. Aggregation is important for the efficiency of routing, of the routing tables, to keep things aggregated in one prefix. So what you have here on the left side, so the allocation that you receive from the RIPE NCC and the assignments that you are making from that allocation, this is what we call the provider aggregatable space, PA. So all this, it's a hierarchical way of distributing the address space, and that in a way that is aggregated on the provider, on the allocation. The catch here, from the end user perspective, is that if an end user, let's say a customer, or if you are a service provider or something, if you have a customer that is it's getting address space from you, and with it actually in using your own network to announce its prefixes, this address space belongs to your allocation, to an LIR's allocation. The thing is that if one day the end user decides to change provider for whatever reason, what you'll have to do is to give back this address space to the old LIR, and by getting another provider and getting addresses, it still needs some address space. By getting connection to the other provider, it will need to have address space from this other LIR, from this other allocation. So address space that is on this side of the diagram, the PA space, always stays with LIR. In other words, if the new end user wants to change the LIR, wants to change the provider, it will have to renumber their networks because they'll have to give back the block to the previous LIR and get new assignments from the new LIR. In some cases, this is not really desirable to have in very specific cases where renumbering becomes a big problem, like complex networks. Example, network of like a bank network that has assignments for different ATM machines. So just imagine like something that is very corner cases, which is has some features that make like this type of renumbering process really complex. In some cases, there's a specific type of address blocks which fall outside of this rule. So this is what we call here the PI assignments or provider independent assignments. The main thing with this type of blocks is that they come directly from the RIPE NCC pool, as you see here. So they come directly from here and they are assigned directly to the end user, independently from the provider. Therefore, PI provider independent assignments. The thing with these assignments is that you are sort of independent. So if an end user if an end user, for example, wants to change the LIR, wants to change the provider, it changes and it keeps this address space with them, so it's portable. But then again, the downside of this is that it's not so good for the routing tables. It creates the aggregation, so that's why the policies make it specific that it can only be assigned to end users with specific specific use cases. So this is the main model for the IP address distribution. It's not so different than IPv4. What you see different is the amount of address space that's being given out. So, and in IPv4 you had the whole /0, the hands of IANA. Here we have a /3. Then from the RIR pools you had blocks of /8s in IPv4. Here you have a /12s. And by the way, these /12s have only been given out once. So the first /12 that has been put in the RIPE NCC's hands, and I believe in the other RIRs is still the first one, that where the addresses are being given out from. And then the LIR, so each of your organizations can receive minimum /32. So that's a lot of address space to start with, but it keeps things neat and aggregated. And the size of end user assignments, I'll just show it in the next slide, is also different and much higher number of addresses or blocks. Just want to highlight one thing. Here on this diagram, you actually see things a bit hierarchical, as in you have IANA on top, the RIR here, the LIR, and then the end user. But the only hierarchical aspect here is the distribution, but because these organizations are not like really having authority over the others, so it's different collaboration, but only the distribution is meant to be hierarchical. Now, when it comes to assignments or the subnets, so what you can see here, like in IPv6, or let's say in IPv4, you think of whenever you're thinking of creating addressing plans or creating subnets for your networks, you'd be thinking on the individual IP level, right? Also because it was a small amount, it's a scarce asset, so you want to save it as much as you want, as much as you can. Think of how many IP addresses should I assign to this specific network. Well, in IPv6, everything changes. So in IPv6, as you see on the first line, every subnet should be a /64. Actually, instead of thinking of the IP address level, you should think of a subnet level, subnet unit, as in like the minimum unit should be /64. That's like the base unit. And yeah, we don't have time to in this webinar to go into it, but there's reasons. That's also the way that IPv6 was designed to work. It takes an important role in if you're using a stateless address auto configuration. That's a way. That's on methodology. That's on set of processes that where IPv6 is meant to work with, where the device is assigned an address automatically. Yeah, to put things very simple. But then you need to use the /64s as a minimum subnet size. Also, point-to-point links, you should also reserve a /64 for each point-to-point link. So yeah, the /64 is really like it's meant to be the unit of when you think of especially of addressing plans and subnets. So minimum /64, and we also getting into assignments here. So actually on the last bullet, let's say customer assignments should actually think as minimum /64, but actually can go all the way up to /48, which is 65,536 subnets. That means that when you're assigning space for a customer, you can go up to /48 without even asking us for any authorization or anything. So /48 is sort of a threshold where up until /48 create any assignments you want. You can still create if your customer requires even a bigger chunk, that is still possible. Then you need to send a request to us to the RIPE NCC. But up to /48, yeah, you can do it. Well, especially if you're a service provider with business customers, it is not such a huge deal. I mean, /48 will, if you assign a /48 for a business customer, they will have enough space to create their own subnetting plan and will not need to come back next 2 years for more addresses. So things will also be much more neat and tidy. Everything, yeah, or the aggregation will be much more efficient. And that's also one of the main things with IPv6. Okay. And the allocations, well, as I mentioned already, if you require an allocation from us, you have a /32 minimum, and you can actually get more up to /29, no extra documentation needed. So yeah, IPv6 sizes are much larger of addresses that we give out. Yeah, I mentioned this already for the customer assignment. So up to /48, you don't need any approval, and more than a /48, you must send a request form or make a sub-allocation, which I'll mention later on. Now, one of the main things is that every assignment must be registered in the RIPE database. So any assignment for any customer network or even for home users, like DSL pools, everything must be registered. And you may think, wow, that's going to be a lot of work, a lot of assignments, a lot of objects to be created in the database, right? Not necessarily. There are some ways with IPv6 that you can use that, yeah, create some kind of objects that will imply several assignments being done. But we'll get there in a second. Now, the database objects that we'll be looking at, so the main ones from this aspect of registration are the maybe some already familiar to you. INET-num objects represent IPv4 address ranges. INET6-num objects that represent IPv6 address ranges. Then you have AUTNUM objects. These are the AS numbers, so autonomous system numbers represented by AUTNUM objects. And then you have root6 objects, which is the equivalent to root objects that you had in IPv4. And these are objects that put together a prefix and an AS number. So when an AS number is announcing or originating a specific prefix, this should be registered in the database as a root6 object. And then you have a domain. Pardon. Domain objects. It's used to set up reverse DNS. And the maintainer is protecting other objects. We go into more details on how these things work in our RIPE database basics webinar. But yeah, so this is just kind of to put things a bit in perspective. Actually, I'm going to my browser now, and I will show you a bit like what would you see if you query for an IPv6 address. So I'm going to use my the address I'm currently using. So if you go to ripe.net, well, your public IP address will be shown here immediately. So I'm going to use this as an example. Zoom in a little bit. And let's see. If I enter, what do we see? So very briefly, like the main things that you'll see is, and I'm going to zoom again. Yeah, So the first thing I get is an INET6 num object. So this is the, if I enter an IPv6 address, what the database will get me is the block where this address is part of, and it will be, in this case, /48. If you do that with your own, well, whatever you are, with your own public addresses, whether it's IPv4 or IPv6, well, the IPv4 you're going to get something different. You're going to get an INET num object. If you're using IPv6, then this is what you're going to get, something similar. An INET6 num object, you'll see the block size where it's part of, /48, and some other some other information about this address range. Like in our case, I can see it's a RAP NCC network. I can see the org attribute is the organization. So there's an object representing the organization that's responsible for this address space, and I already see it here. This is the organization object. The database returns by default some objects are returned by default, like organization objects or yeah, the administrative context or technical context. So I already got it here. So I can see the organization responsible for this address space and plenty of contact information to get through. So if you would need to contact anyone about this address block, here it is, all the information, as well as administrative contacts, technical contacts, and so on. And you would see here all the further contact information. So this is on the query perspective. So that is how you would get information you would get from an IP address in the database. And yeah, you can start making some parallels with what you had in IPv4. So if you were also been doing it with managing the database registration from IPv4, then you can also see that the principles are the same. So for allocations, whether you have in IPv4, you have an object with a status allocated PA. Oh, by the way, yeah. So you have each object has a status, and you can from there you can see if it's an allocation. Sorry, if it's an assignment, if it's a suballocation or a PI assignment, and yeah. If it's IPv4 or IPv6, the status is slightly different, but it's just a syntax basically, because it means pretty much the same thing. In an INET num object in IPv4, for an allocation you had allocated PA, whereas in IPv6 you have allocated by RIR. For assignments, whether you have assigned PA when you had assigned PA in IPv4, for IPv6, well, there is a slight difference here, and I'll show you the difference in the next slides. But let's say the most common assignment block is the assigned status, this one here. And if you can, there's a way you can group several assignments under one object, and then you call it aggregated by LIR. I'll show you in a second how this works. Suballocations. This is a way to delegate a block from your own allocation to be managed by another organization. It's called a suballocation. I'll also explain it in a second. But in IPv4, you had suballocated PA, and in IPv6, you have allocated by LIR. And for PI assignments, so the whole thing I explained before, this is actually keeps the same status. So IPv4 and IPv6, they have status assigned PI. Okay, so let's look at each status individually. What does allocated by RIR means? So that is the allocation. This is the address space that is given by the RIP NCC to each of you, to the LIRs. And it is basically where, so here, it's the minimum size. So you'll see a block that is with the status allocated by RIR, and basically the minimum size that you'll get is a /32, and yeah, that is the block that you will be doing your own assignments from it. And yeah, it would look something like this. So in this example, to be an LIR getting a typical /32 allocation, you see the prefix here with its size here, and then similar to what we've seen in the real database, the example I showed, you have the net names. You see the country where it's being. Oops, sorry. You see the country where it's being used. This example would be the Netherlands. link to the organization object and to the administrative and technical contacts here, and here the status allocated by RIR. The assignment objects, this is it's a normal assignment that you take from the allocation and assign to a customer or to your own network. Imagine here you have this /48 for yourself, for your own POP, for one of your POPs. Assign a /48, and all this range contained in here are used by yourselves, and you create an object in the database representing that, giving the status assigned. Let's say you also have a customer, like an office. They also need a /56, and they're getting a /56 from your allocation. So you take this chunk, register it in the database, give it a status assigned, and yeah, it's very simple. If you're using that with IPv4, it's the same principle. And the /64, it's a minimum assignment size that you can create. The database will only accept the minimum of /64. And again, previously mentioned it, if you need more than a /48, then for an assignment, for example, either for your own infrastructure or customers, you can still do it, but then you need to send a request form to the RIPE NCC via the LIR portal. Up until /48, you can do as you please. Now, what else? Oh yeah, it's also the example. That is the status assigned here. It's it's a normal object. In this case, /48 assignment. We just give it a status assigned, and yeah, works pretty much the same as IPv4. Now, the new thing comes here: the aggregated by LIR. That's the new flavor that comes in with the IPv6 registration. And the reason is so what this object does is to group several objects of the same assignment size into one object only. Why is that? Let's suppose you are a DSL provider and you determine that you're going to take a /34 out of your allocation and you're going to assign it to a specific residential area, and you're going to give all your home users /56 blocks. That's fine. The thing is, if you follow you must follow the policy, and the policy says that every assignment must be registered in the RIPE database, which would mean, in theory, that you need to create a single object for each home user in the database out of his /34. Now, as you can imagine, you will not be very happy with it. You probably will need to hire a few extra people just to do this work. So yeah, that would not be the best thing to do. But therefore, there was this other status of assignments that was created to cover these cases, which is the aggregated by LIR, which basically makes it implicit. The individual assignments are implicit within a bigger object. So in this case, let's say you have this /34 for the residential area, and you know that for each home user, a /56 will be created. So that means you just create this main object, and it's a good example here. Okay, here in this example, I have different numbers, but let's say we have a /36 then. I'll restate my example. /36 will be for the pool for the specific residential area, and for each user, each customer will get a 48. We'll get a /48, and so you create an object with aggregated by LIR and enter this attribute assignment size 48. So it's implicit that within this /36 there are many /48s being assigned. Okay. That's just it. So you don't need, of course, to go there every time you get a new customer, create a new object for them. This is implicit by this object. Actually, I'm going to show you how to do this in the database. So I'm going to my browser, and I want to go to the RIPE database interface, to the web updates. So I go to RIPE database here. In fact, I'm going to use the test database because do you know what the test database is? Well, it's just it's a copy of the RIPE database infrastructure. but not the content itself, but it's just the database software, where you can just, the idea is really that you can play around with. It's a sort of a sandbox. You can just play with it, create all the objects you want, practice some things, and then every night is reset. Every night all the content is reset. It's got also some test objects there, but yeah, you can play around with it. So I'm going to use it for this demo. How to get there? Well, you actually have to go to the query interface first, and then there's a link here for test database, and then I'm in it. And here I can go to create an object. By the way, if things are too small, I'm going to try to zoom in, but if it's too small, just go up to the top right of the panel and just make it full screen. It will probably be better. So I'm going to create an object, and yeah, so actually this is basic knowledge for the RIPE database. You need to be logged in with your RIPE NCC access account. So here as shows that I'm logged in. I can only create objects if I'm logged in. So if you want to create objects, well, create your access account, and then you'll be allowed to. So what I'm going to do, choose the object type. So I'm going to create an inet6 num object. So what I want to do is like that, is create the like a /48. Sorry, well, bigger than that, like a /36 block with many, let's say, /56 assignments inside with aggregated by LIR status. So inet6 num object, create. Now I have to choose a maintainer. So this is one of it's the way to protect your objects. We explained this in the RIPE database basics webinar. So I need to come up with a maintainer that I know the password for, and I'm going to do this cm30-mnt. This already exists in the test database. Now the database is asking me for the password. Yes, I will enter it. I submit it. Yeah, so it's there, so that it will use this maintainer. Now, okay, now I will just enter the range that I want to create this object for. And if I'm not making a mistake, well, this should in principle work. Yeah. So I'm creating a I'm picking up a /36 block from this example allocation. And I'm going to make many /56 assignments. This would be a net name. Okay, this would be a demo broadband pool, for example. Something like that. Well, I'm in the Netherlands, so I'll just enter the country code for NL. Now, administrative and technical contacts, these are usually either person objects or role objects. And very briefly, these are objects that contain contact information, either individual contact information as a network engineer or a customer support, or the role object being the whole department. And these objects should also exist in the database with all this information already. So in this case, we already have some objects created there. I'm just going to enter the reference to these objects, the nick handle as we call it, and I'm typing it the right one. Yes, it's already suggesting it. So TP30, I can actually add the same one. And the status, that's going to be aggregated by LIR. Now, am I all good to go? Not yet. I still need one attribute, which is not shown by default. If I'm using an aggregated by LIR, I need to enter the assignment size, right? So, and I'm creating /56 assignments for each customer within this block. So, what I need to do is add an attribute, assignment size here. Here it is, and now I just type 56 or whatever assignment size you want to give. And if I didn't forget anything in this estimate, yes, it's created. So we have an inet6 num object in the database. In this case, the test database, but yeah, it's a /36. These are all some other information, contact information, and so on. But it's an aggregated by LIR object with an assignment size of 56. Yeah. Okay. I see. Sandra, which is not really Sandra. She actually was replaced by another colleague. called Ferenc. You'll show his face in a second, or you can just show your face if you want. Okay, so don't show your face eventually. Okay, I'll go back to the slides. But Ferenc is now replying to all your questions, and I think he's busy. You keep him busy. So continuing. So that was the aggregated by LAR. That is actually the main difference between IPv4 and IPv6 registration in the database. All the rest is pretty much the same concept. The next status is allocated by LAR. These are the sub-allocations, right? When do you use this? Well, suppose you are you're a ISP, service provider, content provider, and you have a customer which is a big company, or in any case, their goal is to they're opening like several offices or several representations. For example, if they're a gas stations, if they're like a company who deals with gas stations, opening several gas stations over the next 2 years in several locations. So they want to have a block for their own, but that they want to maybe not use everything in one go. So like I said, they have a plan over some time, and they're going to use several chunks from that block over this period of time. And you want to keep things aggregated. So one option is to create a sub-allocation for them. So in this example, you take a /36, give it to this company. It's created as an allocated by LAR object here. And then, then over time, they will create their own assignments or aggregated by LAR. So from this /36, then it will be over like next 2 years, create /40s, for example. You can still manage this yourselves creating yourselves the assignments under the allocation, or you can actually, if they know what they're doing, they can take care of this registration part themselves as a third party. So there's some mechanisms to delegate this ability for them to create their own objects, but that's possible. Then this is how such object would look like, as in this case, and different numbers again. It's a /44 sub-allocation to a big customer network. Status allocated by LAR. That means it's sub-allocation. And yeah, the maintain lower here, without getting too much detail on how maintainers work, because we don't have much time. But the maintain lower, it's an attribute that basically gives the authorization for whoever holds this maintainer being sort of the lock and its key to gives an authorization to create the assignments under this object. So if this big customer has its own maintainer, so it has its own set of authorization rules, and it's called big customer MNT. Adding their maintainer as a maintain lower in this object will allow them to create smaller blocks out of this /44. They are really authorized to do that. If you still want to do it yourselves, if your organization still wants to keep control and make this management yourselves, then don't do the maintain lower. You'll still be the one. Your maintainer will be the one there, so you'll be the one still authorized to do that. It's up to you. And finally, the PI assignments. These are, it works pretty much as IPv4. These are, like I explained, blocks that are assigned directly to the end users. They basically are being held by the end users, regardless if they keep the same provider or not throughout time. The thing is that the minimum assignment size is /48, so each end user will receive a /48, and it has the specific requirements for them to qualify for PI. And mind you, in IPv4 the requirements were a bit more relaxed. An end user could qualify for PI more easily, whereas in IPv6 it's a bigger concern to allow for such deaggregation unless there's really good reason for it. So PI assignments cannot be used for sub assignments. Let's say, so if you have a business customer which is also providing connectivity to its own customers, you cannot use PI blocks for this, so they cannot be sub-assigned. The policy clearly specifies that. So it's really for other specific issues like complex setups of creating very complex processes for renumbering or stuff like that. But a PI object in IPv6 is really pretty much similar to a IPv4. It's just an NCC num object with a status assigned PI. All right. Now, last bit of this webinar goes into the routing registry. If you're wondering what the routing registry is, it is just a part of the RIPE database, together with other data sources, but sticking to the RIPE database, it's part of the RIPE database that deals with the routing information. So the RIPE database as a component of the registration part, which is what we've been looking at. So it's sort of information that tells who is responsible for each IP block and contact information about it. And then there's a component of the database, which are just database objects, but it is the information there is about what's happening or what's supposed to be happening on the routing tables on BGP, for example. So you have objects that, as we've seen, they specify prefixes, prefix blocks, the INET-num objects or INET6-num objects for IPv6. And we have also these objects, the out-num objects, that represent AS numbers. By themselves, they don't say anything of who is announcing what. You can have an out-num object and an INET6-num object separately. They don't mean anything of what's happening on BGP, of what's being announced. However, you can create that information in the database by creating a root6 object, like here, where you do specify the prefix and the origin and who is announcing the originating the prefix, and you put the AS number. There has to be an out-num object corresponding to this AS number, but then you specify the AS number in the origin attribute, and there you have that information. This is not like a requirement from the RIPE database itself to create these root objects, but in most cases, if you're peering with a big service provider or internet exchange points, most of them actually require you to register your prefixes and your AS number in the routing registry by creating these objects, because this is a way that many operators use to keep their filters up to date. By creating these objects, there's also the RIPE database mechanism, authentication mechanism that kind of gives trust, gives some verification that whoever has created the object had the authorization to do so. So this is in many cases is a requirement by some other organization that you're peering with. And actually, in any out-num objects, you have also the possibility to specify more detail your routing policy, and this is useful for in the bigger picture. If all your peers several organizations do this, basically specifying on what are their neighbors, who is announcing what to whom, it becomes easier to create a picture of what should be happening in BGP, and it becomes easier to troubleshoot or to see that if anything is going wrong, like if somebody is announcing things that they shouldn't, like prefixes that are not specifically from an organization. So it is a good practice, even though this is also not mandatory, but it's possible. So just to say that in IPv4 you had also this with import and export lines. In IPv6 you have the same capability, only you need to use MP import and MP export. MP standing for multi-protocol. And then the syntax up until here, or actually from here, is exactly the same as you had in IPv4. So you say from the AS number what you're accepting, or to which AS number what you're announcing. The only difference for IPv6, you need to enter this keywords here, the AFI, which is the address family identifier, and saying IPv6.unicast. That's just the syntax to say it's from IPv6. The principle is the same as IPv4. Okay, now I'll just do a little demo on how to create a root6 object in the database, and that will be very simple. I'll use the test database as well. And if I do create object, same process. So first I need to select which object am I supposed to create. I do want to create, and I'm going to choose root6. I'm going to use again the same maintainer that I was using before. So in real life, we will use yours, cm30-mnt, and I'm going to enter the prefix that is supposed to be announced by an AS number. So these are also objects that have been previously created for these demos. Yeah, I'll just do this, for example, /36, and the origin will be AS130. So this is also a previously created object. So that will mean this AS number is announcing this /36. And again, if everything is okay, yeah, object was created. So nothing new. This is exactly the same as IPv4, only the object changes from root to root6 object. Okay. Yeah. So going back to the slides, and yeah. So coming to the last bit of the webinar, a quick word on domain objects. So what a domain object is, it's about reverse DNS. To set up reverse DNS, you have to basically create a delegation for the prefix that you are creating the reverse DNS in the IP6.arpa zone. So it's still the delegation still happens in the DNS tree, the DNS hierarchy, although it's in a specific branch of the tree, the IP6.arpa zone. You will need to configure your zone files, of course, with PTR records. So if you have done reverse DNS before, you probably have an idea what I'm talking about. If you never did reverse DNS, then maybe it's a bit more cryptic for you. But yeah, we don't have time to go into further details or any demo, so I'll explain it how we would do it from the RAP database perspective. So you create the PTR records in your zone file, but you need to have a way to tell the root server that how the zone is being delegated, and that is done through the RIPE database, through the domain objects. So you create an object that's domain object, and you enter the prefix in the reverse DNS format that is to be delegated, and then you specify the name servers which are handling this zone. So it's similar to what happened in IPv4. IPv4, you would basically reverse the order of the octets. In IPv6, what you need to do is something kind of like this. So imagine I want to create reverse DNS for the block that contains this IP address. And in reverse DNS, you also need to use classes. You have to, in this case, for example, either use a /48 or a /32 or and so on. So what you need to do now with reverse DNS, you need to uncompress the block that you are creating the domain object for, and then the block that contains this address, and you want to create the reverse DNS for this block is a /32. So yeah, you take the /32 prefix, and what you need to do is to reverse the order of the hexadecimal digits, separate it in with dots, and place it into the IP6.arpa zone, as you see here. In IPv4, you had in other.arpa, and IPv6, you have IP6.arpa. And yeah, mind the lack of, there's no V here. So it's IP6, not IPv6. Good source of typos, yeah. So this will be what you will put in the domain object name, and that's it. Then the domain object, I don't think we have an example here, but domain object, then you'll just specify the name servers and create it, and then yeah, the zone should be delegated. Then the difference, yeah, with the PTR records, when you go to your zone files, yeah, PTR record becomes this very beautiful thing, because indeed you want to create the record for that individual address, and yeah, you have to basically have it in uncompressed format and write it in the reverse order, but every digit, and that's something, and this is how it will become basically. So yeah, be careful with typos, and maybe the best way is to create some scripts to automate this process. But yeah, this is the principle is the same as with the reverse DNS for IPv4. It's just really the syntax again that changes. Oh yeah, here actually we have the example. So this would be then how the domain object would look like in the database with the same example. So it's a domain object. So we basically reverse it. This is the /32. Actually, this is yeah. Yeah, so you basically reverse the order of digits. This will be the name of the object inside the IP6 ARPA, and then these are some description, some contact information. But then here you have the name servers that are handling this reverse DNS prefix, reverse DNS zone, and that's it. This will be the way to delegate the zone. The domain objects, like I said, they are sort of classful in that sense. Only you have to create them either for /48 or for 32s, and you have to have a minimum of 2 name servers for redundancy. But that's it. And yeah, that actually brings us to the end of the webinar. And I would like to ask if you have any questions still for what I've been showing you. I see Ferenc is typing a lot, so there are some questions being answered. Is there anything you want me to read? No? Okay. So yeah, Ferenc is still typing. And yeah, so well, we'll still be here for another 10 minutes after I switch off the microphone, so you still can think of any questions you may have. I'll just also mention, if you want to know more about IPv6 and the RIPE database, one good source is the academy.ripe.net. That's our e-learning platform. Lots of resources are there, lots of content, but actually they're in the form of courses, so you can take a course from beginning to the end. You'll have a lot of activities to do, so that will test your knowledge and actually get your hands busy with doing some things, both in IPv6, RIPE database, and yeah, LIR procedures. So there's 3 different courses at the moment. We are actually currently adding more things to it. So take a look at there. You only need to log in with your RIPE NCC access account and yeah, do the courses. And in the end, actually, you can get a certificate if you finish the courses, because you'll have several exams and activities that you need to pass. But if you pass them with a passing grade, then you actually can get your certificate. Follow us on Twitter at Training RIPE NCC. Keep up to date with new webinars, courses, and so on. And that's it for now. So I hope it was a useful webinar. And yeah, like I said, we can still be here for a bit. Can ask further questions. And I'll just add my email and maybe Ferenc's email if he's okay with that.
Well, there's a question for connection between my customer's device, mine and my customer's device. Is it better to use public or IPv6 or private IPv6? Any good tips? So not private.
No, yeah.
The thing is either you use public or you use link local addresses.
Yeah.
That depends if it's point-to-point.
Yeah.
Then you can use link local. Otherwise, use public.
Exactly. So I don't know if Ferenc's voice came through the microphone, but I'll repeat the question and the answer. So yeah, for connections between Michal asking for connections between my network and my customer's device, should I use public IPv6 or private IPv6? Well, you should definitely use public IPv6, because that's the way IPv6 is designed to work, is with the end-to-end connectivity. Private IPv6, the ULA, unique local address, that exists as well, but the idea is to use that for networks which are not connected, not going to connect to the internet whatsoever, like test labs or so on. The thing is that IPv6 is not supposed to use NAT, so you will need public addresses. Now, what you may think is, what about security? Because you have to think, okay, I had for IPv4, I used NAT. I would be kind of saving addresses. I would have some level of security because, yeah, people cannot see what's behind the NAT. But that is an illusion, because the security should be given by the firewall, right? And that's the way with IPv6, you use public addresses and then implement a layer of security via the firewall and other ways. So public addresses, definitely. Okay. Yeah, for one connection, yeah, that's the thing. So The default answer for me is like, should I, so Michal is asking, should I use /64 for one connection, or can I divide one /64 for smaller subnets? For a connection, point-to-point connection, so the default answer is yes, use a /64. So each point-to-point connection is you should reserve a /64, even though you will in practice only use two addresses, once a /127 within the /64, right? So each end of the connection. But there's one thing here, is that this was the original specification, the original RFC, so /64 per point-to-point connection. But recently, another RFC was published, and it actually yeah, recommends using a /127 for point-to-point connections as well. So that is possible, but our recommendation is make sure that all your equipment can handle the new RFC. That is important, because if there may be the case that your firmware, your setup actually does not support the newer RFC, and you have a problem then. So we can use the new RFC, and I would like to give you the RFC number, which I don't know by heart, so we could look it up. I can do it in a second. The newer RFC allows for it, but you have to make sure that your equipment supports it, right? So if in doubt, use the default answer, which is /64 per point-to-point connection. Yeah, yeah. Do not subdivide the /64. That is the problem. That is correct. I allocated one /64 per point-to-point and use 127 subnet. Yeah, that's correct. Within the /64, you use the /127. That's correct. I'm going to look up the number of the new RFC, because I don't have it on on the top of my head, and I'll type it in a second. Well, it's not wrong. It's okay. Okay. Carsten is asking, can you explain the relevance of the outnum object under routing once more? Okay. So the outnum object represents the AS number. So you have an AS number from RAP NCC, right? So you are announcing your prefixes from that AS number. And so if you have a specific, like /32, you're announcing it from that AS number. So from the RAP database, the AS number is represented by the outnum object. Now, what you need to in the database, you can add this information on this routing information there by creating the root6 object, which basically puts together the prefix and the AS number. So the prefix in the inet6 num by itself just represents who is responsible by that prefix, and the outnum represents who is responsible by the outnum. But in the routing perspective, it doesn't mean anything, because it doesn't say who is announcing what. But with the root6 object, then you can add the outnum object as a origin, and then the prefix as the prefix being announced by the outnum. So with that, you can make a statement that this prefix is being announced by my AS number. Or if you're in doubt, for example, if you see some announcements on your on the routing tables that you're not sure should they be coming from that AS, you can see that if in the database there is if in the database there's a root6 object that says there's an origin of that AS and that prefix, then it is a good then it's a good proof that is meant to be announced, because to create that root6 object, there had to be some authorization process in place to have the object there. Does it answer your question, Carson? Yes. Okay. Sorry. You meant I'll explain that. So yeah. if you worked in IPv4, you had import and export lines. Have you worked with it before, with those before? Because the point there is, yes, okay. But okay, so if you're familiar with putting your routing policy as import and export lines in IPv4, it's exactly the same concept with IPv6. The only thing it changes is the syntax. To create the same lines in IPv6 for IPv6 routing policy, you just have to add the AFI IPv6.unicast, and then you have the same statement. That's the only difference. And you can also use the MP import also for IPv4 if you want. Then you have to specify AFI IPv4.unicast. Yeah, but it's really just the difference. The difference is only in syntax. So yeah, so if you've done the same with IPv4, you can just do the same with IPv6. Just add a MP import, MP export, and then add the same add your policy with the specific keywords. Yeah. I'm gonna type my email address if you have any more questions later. Inferences. Uh, yeah, it's exactly the same thing. It's really just add those syntax, those lines. It's just change the syntax, but the idea is exactly the same. Okay. Well, I see for now there's no pending question. If you have any other question, just send us an email, or we'll still be here for another 5-10 minutes with the chat window open. Yeah, I hope it was useful, and we'll send you soon the link with for the recording. And yeah, well, maybe see you in the new webinar or training course soon. So yeah, bye.